Well, happy Thursday. Hope the midterm went well. Ideally, again, that was pretty easy. Sort of a checkpoint. If it wasn't easy, let me know. We've got to chat and see what's not clicking with Java here. Um, I don't think anything was crazy hard on it. I think everything went pretty well with the project. I only got a couple questions on the Java FX side of things, adapting your Monopoly game. Um, I don't think I want to spend a lot of time going over a solution for it. My apologies, but there's a lot of like building out the UI that's just kind of slow. Um, if anyone has one they want to demo, I can download it and run it if you want, or we can do it after at some point. If you really like yours, I want to show it off to everybody. That'd be fun. But again, a lot of the UI stuff for just mapping. Here's what the button does, and here's where we interact in our classes with it. But we've got a lot to get to today. We're going to cover most of the advanced Java stuff and then dive into databases. I don't think we'll get through all of chapter 19. We've got next week to finish that up. I'm going to look at some more of the advanced database stuff here as we pick up our last project, because that will be our database-based project. And for this one, you'll be welcome to work in groups of 3 for this, because then ideally you'll have who your final project group is. Then you can essentially give a trial run to those people, make sure they're actually going to contribute and don't leave you behind. And if they're a good group, great. You can keep working them, keep that group for the final project. And that should be a lot of fun. So we nothing super large with databases, but we want to have a chance to explore how we interact with databases. Um, I'd love to use a real full functional enterprise style database, but getting that installed is a small pain sometimes. So it's a little easier to use our file based database, which is SQLite. And those are fine. Uh, they serve good purposes, but they're not any stretch of the imagination enterprise style database. Um, but the same way we interact with it is how we interact with an actual database. So it still works. We just kind of host it locally and it works out pretty well. So for working in a group, we just need to make sure that the database file itself gets added. So I can show you how we can do that today. And then we'll pull up some more of the advanced fun stuff next week and then hopefully wrap up our databases. Yeah.
You still have the option to host on Firebase or Azure?
Yeah. Connecting. Yeah, if you want to, if you've got one that,
Mobile React application?
yeah, yeah, if you want to do something like that, that's fun. Um, Usually it's a little harder for me to get everyone to set up. That's why I avoid that most of the time. And we just start local, but the same principles apply. Uh, so usually I'll use the MySQL or MariaDB local database. That one's a good copy because you get a lot of MySQL databases online and things like that. Or
Hive's good too.
hmm,
Hive's also good.
Hive? No, I don't think I've used them before. Okay, they're online hosts.
No, local.
Oh, local. Okay. But we'll do some fun stuff with that. And then when we get to our multi-threading and networking based project, that will also use a database to store our information. So that's persisted around in a central location, or again, just a file. Again, is fine for now. But we should have some fun with that. So let me pull up. Oh my goodness, that.
You would want to use SQLite, so this Hive is no SQL. It's documented.
Oh, okay. Yeah, we were going to focus on the transactional ones. Doing the NoSQL's a little bit more complex. So it's yeah, you can do a lot of fun stuff with it, but yeah, I don't think we've got enough time to get into it at the moment. Why can I not remember the name of bookcase? Vital source. There we go. Let me grab this. Make sure we get in line with all the chapters here. All right, so this is the more concepts and skills section. So strings, we don't have to do a whole lot with. Just know you can do fun things with strings here. Doing string splits and joins is pretty common here. I don't think we got into that yet. So this one's probably worth looking at real quick here. It's got some nice handy shortcuts. We don't have to do too much. We'll get into some fun collection stuff. A little bit with lambdas, expressions, and streams. We've done some of the lambda notation where we looked at using code first approaches with Java FX. You can give it that anonymous function. This is what I want my code to do without defining everything, which is fun. I don't think we need to do much with recursion. Hopefully, you're sick and tired of that recursion after 200. and going on from there, and then more in 350. Are you in 350 now? You got through it already? Okay, so you're tired of recursion. That works the same way. That's all fine. Dates and times is nice. Java's got some nice libraries. You don't want to do this stuff by hand because dates are awfully complex, and then we'll get databases here. So we fire up IntelliJ. Let me just make it like a new project. I'll just call it more Java. And this is week 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, week 9 already. More Java. Sample code. All right, cool. Close. What did I click on? Nope, that's not the right button. How did I get to Kotlin? All right, 9 Java. Sorry, that is not what I wanted. GitHub 296. Trash that. Try again. All right. See if that works any better for us here. Yeah, that looks a little better. Thanks for all this extra comments. We don't want any of that. Goodness. All right. Right. So with our string splitting and joining, if we had some long string that we wanted to go and do something with, so a lot of times, like looking at file paths, they have a lot of slashes in them. We want to look at different folders. Anything that's got a repeating token. I don't think we looked at doing comma separated files before. We were doing file input and output. That's another common one, but again, that gets weird when you've got quotes in things. So it's its own small hassle here. But if we were to have some string, like, I don't know, some long sentence, and what's some example text? Now, what's whether that's actually English, though? Dummy text generator. That one's not English, but that's fine. That'll do. So here's some long string here. This is, I think, Latin, right? The lorem ipsum text example here. It's silly, but um, if you wanted to convert all this or separate it all by spaces, right, we've got, instead of having to find a space and then take a substring and find a space and take a substring and find a space and take a substring, it's a lot of work. There's a built-in way to do that. So we can get a string array. We'll call them like the tokens is my long sentence, and you say dot split. And what do we want to split on here? So we can give it a couple different options. You can give it the character, a given string. You can use regular expressions if you like those sort of things here. But essentially, just splitting on a space is going to be easiest for us here. And then we could say for token and tokens, we'll print out a token. Look at that. Helpful suggestions here. So we've got every space now has been separated into an array for us, right? So it splits it. So splits very handy, and you can split on any kind of character or expression that you want here. Um, so I guess the char would be the single quote. Is it not? Is it not taking the char? Whatever. I will just leave it as the quotes for now. So lots of easy ways to split stuff. If you're using delimited files, you can split on commas, split on pipes, split on tilde characters, whatever sort of thing you wanted to split on is pretty handy. And then we can do the opposite here. We can take an array or collection of strings, we can put them back together with a given character. So if I want to say I had a list of values here, we have a string array of foods. What kind of foods do you guys like? Popcorn, pizza, hamburgers. Ribeye? That's not how you spell ribeye. How do we spell ribeye?
I think that's good. He has a little dash.
Really? Okay, interesting. I didn't know that. No, we don't want to loop through. So now, if we wanted to go print these out and like give a nice little list, hey, some of my favorite foods are, right? My favorite foods are, we'd have to loop through this list, right? Printing, and then we'd have to manually add commas, but not after everyone because you don't want to add a comma after the last one, right? Because that gets to be kind of ugly looking. So what we can do instead is we can join them together with a comma and a space. So then I can print out, uh, for to print my foods dot, no, I'm sorry, the character we want to separate these with. So a comma and a space is the character we want to join all of these with here. We call join. So there we go, string.join. What do we want to put them together with? And then what is the collection here? I'm going to use foods. So we're going to take the foods collection and put them together with a comma and a space here. That way I don't have to deal with the comma and the space on the last one here because it only puts them in between all of them. This one prints out pretty nice looking here. So join is a pretty handy way to put things back together to get a nice looking output here. And not just for like comma separated things, but anytime we've got a collection, we want to do something to represent it here. This comes out really nice looking. So if you had like a list of properties that someone owned and you want to list them all out for them, maybe you join them together this way, or you could join together with a new line. So you can have just a label that had the list of properties. We could have used a string join off of their list of property names or something like that. Lots of fun things we can do with join just as a nice shortcut. So you don't have to do this by hand the hard way. We've got some great little library options for splitting and for joining back together again. All right. Um, that's probably all we need out of that chapter then. Um, yeah. Oh, string builder. So just a mention for string builder here. Um, when we're working with strings, because strings are immutable, every time we append to a string, it has to create a new string in memory, right? So if we said, hey, my string of, I don't know, some list starts off with nothing, and we said for item, we can go through this one here, right? Why not here? We'll go through this one. Um, our bunch of tokens here. If we wanted to do something with our sum list here, um, add to it the token plus, I don't know, a comma or something silly, right? We'll go add to it. Now it's warning us we're doing string concatenation in a loop. And IntelliJ is smart enough to know this is a bad idea because this, if it's really short, hey, it's 5 things, it doesn't really matter that we built 5 different strings. But this sentence was kind of long here. Like this was, I don't know, 100 or 200 strings. We've made 100 to 200 strings in memory. That's a big waste of the memory and processing power to make a new string, add to it, make a new string, add to it, make a new string, add to it. So string builder uses a buffer so that we can keep adding to strings in memory without having to throw out the old ones. So it's an efficient way that Java can store these things here. And it's even suggesting, hey, we do that to use a string builder and you append items to the string builder. So you say, hey, append this string to it, and it will handle it in a memory efficient manner instead of throwing away the old string, 10,000 times, whatever it happens to be. When you're done with it, you just print out dot to string. You take your string builder and you say dot to string, and then we'll spit it back out. It's telling us it's redundant at this point here. It's unnecessary because we're printing. It'll automatically call to string, but if you're not printing, you'll need to call the to string on it here. So this is the memory efficient way of making a string from tokens, right? And use to string to get the final string out. Right. So if you're doing something that's doing a lot of piecing together, string builder is definitely the way to go. And thankfully, IntelliJ suggests that for us because that's the right way to do it, which is cool. All right, a couple items with collections. You can specifically get a linked list if you want a linked list. Again, for the times when you need that kind of performance where you need to be able to add and remove at a given index in a list, and you know that's what your app is going to do. So you want that kind of performance. Right? That's why we study these things and build them from scratch, not just to torture you. but so that you'll understand why they're fast at the things that they do, you can use the Java linked list from the library. Please don't build these by hand. We only do that just to learn them for fun. Um, Sorting, there's a built-in sort. And then if you want to sort custom objects, this is super cool. So if we have another class here, make a new Java class. Um, we'll call this the food class because I'm hungry. I did not get dinner on the way. I was running late, which is a bummer. So I'm going to be hungry all night long. It'll be a long night. I got my coffee though, so that's good. So food, we probably have a private string for the name and maybe a private double for the cost or something, and a private int for quantity, right? Great. And then we can go through and generate all the things we need here. So let's go and generate a constructor that sets all of these things here. And let's go and generate our gets and sets, getters and setters. Sure, we'll do those. Now, there's another generate option here you might have saw. We'll see in just a minute here. If I want to make a list of foods here, right? We did our other list here. So let's do a food array um, of foods. Oh, we can't call it foods though, right? Here's my list of food. And then there's a new food. We'll put 5 of them in there, I guess. No, 4, right? We had 4. So my list of foods at 0, right? We can assign a new food given, what do we have? Popcorn. How much does popcorn cost?
700.
700. Oh my goodness. All right, that's some good popcorn. Is that dusted with gold or something?
Yeah.
Probably just one of those then, right? And then we'll do some new foods. Look at that. Pizza, chicken. Come on, one more. Oh, that's right. That's right. There's only 3. And it stopped suggesting. So, sure. Pizza, chicken, beef, why not? I like how the cost just keeps going up. If I wanted to sort these things here, right? What is that one? Import. Is it tilde? And utilities? I really don't remember now. Okay, that's fine. We'll go look at sorting here. How to sort items in a collection. We'll go look it up. This is why we have a textbook, right? Okay, it is collections. Good, 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 good. That's what I thought. So utility dot collections. There we go. I was going to do dot star, but that's fine. So we call collections dot sort, and you say, okay, what list do we want to sort? Well, I want to sort my list of food here. And now it's mad at me. It says no instances of variable t exist, so food conforms to list of key. Food is not sortable. Right? It doesn't know how to sort. There's no built-in way to sort here. But if I took my foods here, collections dot sort my foods. Is it really? It's cranky here? No? Uh, Goodness. It really has to be a list? Oh my goodness. List of string. Import new string. List of. Goodness gracious, that's obnoxious. Okay. So trying to sort our list here. Find array list. Oh my goodness. Wow, that was a bunch here. All right, well, we'll change this one here then too. So we want a list of goodness. Array list. Array list of type food, list of foods. Import the array list. List of foods dot add new food. Okay, we're getting there. We'll make it look a little happier here. Um, New array list. There we go. Dot add. Dot add. All this to show you that it doesn't work. What a fun example. All right. Now, doesn't like it. the food needs to conform to comparable of this question mark super T. This is really funky looking stuff here. When we look at template types, say this was the generic type here, it has to be comparable, right? Food is not comparable to another instance of food. Right? We have no way to know what food goes first. Are we sorting by price? Are we sorting by name? Are we sorting by quantity? Right? We sort by some kind of combination of those. We have to go define it. So when you write a custom class here, you have to implement comparable. So, okay, and that was the suggestion here. It knows we're sorting here. So comparable then needs to implement a method called compare to of the type food. Right? So this is comparable to food here. So comparable defines how we do that. So we need to go implement our method here, the compare to method. And this is given a little override, right? We're implementing our interface. It compares to another food, and we need to give it an integer value. So for the integer value, we give it a positive number if we're greater, 0 if we're equal, or a negative number if we're less than, right? That's how we define those. And it's the easiest way to remember that is if you're comparing two numbers, you take one minus the other, right? So it'll be positive if the first number is bigger than the second number. It'll be negative if the first number is smaller than the second number. That's how I always like to remember it there. So all we need to do is figure out how we want to compare these things here. So then here's the other food, right? Sure. So I'm just going to return my name dot compare to the other name. So strings implement compare to. There's a compare to for strings, right? They would just alphabetically sort. Again, casing gets a little funny here, but that's okay. I don't particularly care if my uppercase sort first and my lowercase sort after that. That's fine. We're going to say for sorting food, we're just going to do it by name. That's the only way we want to sort. Right? We don't have to do anything fancier than that here. So now back in main, I can sort my list of food because it implements the comparable interface. So when Java looks to see, can I use this sort here, it looks to see if it implements the comparable interface. Now, the bit of the silly message that was there before, let me comment this out for just a second here again, was saying conforms to comparable question super T here. This is where it gets a little bit silly, but we can have subclasses of food that are also sortable compared to food here. So this question mark is like the anything that will fit here that is that type, right? So inheritance can work along with food being comparable. It starts to hurt your head, like why do we want to put then like perishable food that has an expiration date? It's a pretty common example. We should probably still just sort by name, right? We don't need to do anything special there. If we want to, we can sort them differently. We've got that option. So that's why this question super T is there, right? As long as it's a type of whatever that type's going to be here. Okay. So this is the comparable interface, which is really fun. So if we implement this in our custom class, we can sort, which is pretty handy depending on what we want to do here. All right, so that was sorting here. Um, you don't, yeah, it's custom comparator. The other way you can do it then is you can go give it your own sort with a comparator. So you can give it the lambda expression of, hey, I want to sort them using this particular method here, even if it doesn't have the comparable interface. So you can specify, hey, I'm going to sort them off of this option here. I want to sort by price, right? And then this is the little lambda anonymous function. You'll get a negative number, you'll get a positive number, or you'll get a 0, right? If they're equivalent, just checking by price here. This is pretty silly to have to do all that work here because you could just compare the prices. But again, it's just illustrating you can have your own casing in here, right? Whatever whatever this looks like. You can have more code here if you want. Stacks and queues you don't care about. Right? We're tired of stacks and queues, but they work the same way in Java land. And then maps are really fun. So a map is just worth looking at the mapping of here's the key and here's the associated value. Right? So we can build them with hash maps or tree maps. Right? Again, depending on which kind you want to do. Right? If you like sortable trees, great. If you don't care and we just want fast, quick performance, we're going to use the hashing, right? Because we don't need to sort on keys or anything like that. So hash maps are great most of the time, right? So we just use a hash map of type of key and type of value here. So if we wanted to make our little hash map, import java.util. Hash map. No, I don't think I need the map. Okay, so we make a hash map type here. So we can have our, I don't know what we want to have, like stores and foods maybe. So we'll make a hash map of type string and then type food or type array list of type food. Right? You can get silly with these sorts of things here. Right? So this will be a stores equals new hash map, and we can go and put something to add, right? Or we can go get the value associated with that one here, right? So in this one here, hey, let's go add A and W is just down the street from here, right? And then we need a new array list of food. So I guess we should make our array list of type foods here, and then we'll say foods.add new food. What do they have? They have an olive burger. I forget, that was like $5.99 or something. And we just want one of those or something. Sure. And then we can add A&W in the foods list here, right? So it's key and associated value, and these can be other collections of things if you want here, right? But then everything we can get out by the key, right? So our restaurant name or whatever happens to be. I'm assuming you've all gone through lots of these already. If that's not the case, my apologies, and we can spend more time on it, but I don't want to waste a bunch of time showing you how to do it in Java if you've seen it before. Okay, no one looks interested. That's fine. We'll just keep going. So keep those in your back pocket. You can do hash maps as well in Java land. It's all in the library. We don't have to reinvent the wheel here. Java utility library has all the basic data types, data structures here. Just go use them if you want them, right? Don't need to do anything by hand, which is nice. All right, a little bit more on Lambda expressions. So we can use Lambda expressions in anonymous methods if we want. Right? You don't always have to. Right? So there's lots of ways you can do these things, and then you look at different use cases, whether or not these are predicates, consumers, or functions. They can implement different interfaces to take the place of in those anonymous locations there. So some of them are fun, like doing map and reduce in lists. You can do some fun things with your Lambda expressions, like we saw. Hey, I want to specify this is the way I want to do this function here. So these can be a little bit fun here. Like if we go in and we want to reduce a list here, we'll give it, hey, here's my anonymous function. I want to do this thing here, right? So this works out pretty quick. We can give it a small, concise bit of code here nicely, right? This is just giving me all the contacts, right? So again, you can go through the examples, read through them here. You guys actually read the textbook, maybe? That's okay if you, ideally you do the, to, at least for the quizzes, right? Which is one of the reasons I give the chapter quizzes, right? To get people to read the textbook here. Um, I really don't like reading it to you. My apologies. So I just want to highlight some of these quick examples, things that are fun, right? So we can use, oh, here's how I'm going to do these items here. So we want to map by total and we want to reduce by whichever one is the max, right? So lots of fun options here you can use with these ones here, which is cool. So if you'd rather use the method, right, you just say, here's the method, rather than having to define it with the Lambda expression. So it's just a shortcut. It's just a way for us to quickly get some code in there, just like those event listeners. Instead of having to define the entire method here that looks like that, or an entire class, an anonymous inner class that implements the interface of event listener, we just say, here's the code, and it just fits. So that's generally the idea with these lambdas. If they fit, we can use it. It's like a cat. Right? If I fits, I sits. Yes, have cats? No? Okay. All right. So we can look at that. We're not going to spend too much time on this one here. And then dates and times. I want to spend a little bit of time looking at the date API. So how do we use our date API? And we were going to use the later one, of course. We don't need to use the earlier one, which is, it still works, but it's a little nicer with java.time here. We got lots of good options here. And it is thread safe and just works really well. Um, and you can even localize it, which is really neat. Turns out not everyone in the world uses our Gregorian calendar, and some people like to have dates in their familiar format. And there's pretty quick conversions for that sort of stuff here. Um, we've done sort of a bad job in tech of being very U.S. centric and thinking the U.S. is the only market for tech. In general, we've gotten better at that sort of thing here. So this is one of those things that Really makes life a lot easier for people if you're not just using the US market. So java.time is our library for this one here. So we're going to import java.time, time dot, probably stuff. Let's just give me everything here. Bunch of different classes in the Java library. Is it not like, oh, because I already had foods here. We'll just comment that out for a second. I want to make sure this one compiles. So when we're going through and using all of our times here, we just make new ones. So parsing is pretty common. It will create a date and time from some given text. And you can use some different formats here that you want. And you can get pretty crazy here, going down to hour, minute, second, and nanoseconds, if you so care to here. Uh, as far as you want is okay. We just want like now here. We get a time, I'm sorry, date time. No, just now, date time, just a time, not from util. Oh my goodness, it's just a date. There we go. Date now equals new date. Oh, no, that's the old one. I want the new library. I'm doing it wrong here. I'm sorry. Where's my new one here? Local date. Local time. Okay, local date. Let's specify. Local date equals a new local date. Or I want it now. Oh my goodness. Local date dot now. I was typing local date. Oh, I don't need new. There we go. Local date dot now. This will tell me when now is, right, based on the system clock on my computer, which is nice. Um, and we can just print it out. Our now. Oh, it's going to be at the top. Shoot. Um, oh my goodness. Oh, we have the wrong. Foods is no longer an array. We can't join it. Here, that's fine. We can turn it back into an array if we want. Put a breakpoint in here. We just want to see now print out, and it'll be fun. Yay, we get our date, right? So that's just the date here. So if you wanted to print out um, all of the specifications here, you can give it when you turn it into a string. Um, you can get the individual pieces if you want off of your dates here, right, and turn them back into integers or things. There's a day of week class that represents the days of the week. If you want those ones, you can compare. I just wanted to print. Where's my printing one? Adjusting, you can check if it's within a certain time. Is pretty handy. Hey, is it in within a few days? Within how long here? Um, you can add what unit here you want to add. So we're going to plus or minus, add or subtract. I don't know why they didn't give us add and subtract, but sure. Um, of years, months, weeks, days, hours, minutes, seconds. We can add or subtract time from a given time here, right? So, hey, it was now minus 3 weeks or plus 3 weeks or minus 1 day, whatever happens to be here. Um, Also, a couple shortcuts like plus weeks, minus weeks, how long until a given date and time in whatever unit you want, the amount of time between two dates. So anything you can imagine wanting to do with dates, we've got in the library here. Um, I just wanted to, where are the prints here? My goodness. Um, Formatting, there we go. So this is the formatting here. So like our short date format, month, day, year. Um, European format is day, month, year, which makes a little bit more sense. You're going smaller unit, medium size unit, bigger unit. But the best format, of course, is the ISO format where you get year dash month dash day, and then hours, minutes, seconds. So everything is in descending time order, which is the best one here. So use the date time formatter for what kind of format you want. You can get the full text out if you want it to be all that pretty as well, right? Just to get some quick formats. Um, Oh my goodness. Yep. All right. So that'll be format, date time, or format. So we want to print a time dot format. Isn't it formatted? Didn't I just saw it? Just format. Java time dot format. It's just format. Time dot format. No, not that one. Oh my goodness. Date time formatter. Of course, a date time formatter. Sure. We'll steal theirs. Didn't copy. Copy. Why do you make Control C not work? That's sad. I'm going to import date time formatter, and we'll use our now. Import our format style. Very exciting. Format style dot like the full format, and then we can print out our current date time formatted. A lot of work just to get it formatted. Sorry. A little bit longer that way, but that'll look kind of pretty. Oh my goodness. Did it not run? Really? Did it fail? Did unspecified format. Where? Local date? Datetime formatter? Oh my goodness. It did not like my format. Did it have a format? Object. Oh, we're breaking the formatter. All right, it's not worth spending a lot of time on. I'm sorry. I'm sure we can get it working in a minute. That is a sad demo. All right, moving on from dates and times, though. When I talked about databases, this is much more fun, I promise. Working with databases. Now, this is all based on relational databases, which is our common database type. It's not the NoSQL style, the object-based database. That's a whole other story we'll get to here. Um, so starting with what a database is. Now, there's a database course you guys take. I think it's 412, 411, 412. Does that ring any bells? No? Do I have to Google it now? Board catalog. Undergraduate databases? Yeah. CIS. Hang on, I'll find it. Database. Database 421. Sorry, 421, not 411. No one? Database management
Yeah, I
systems?
think that.
Okay. There is a course, and this goes over, again, I think this is a little bit more theory based, which is unfortunate. Not quite as application based, but it's been quite a while since I looked at it. Is that the case?
Yeah, the final project was just integrating like a sound system into a thermostat. Or really,
Integrating a sound system into a thermostat for a database class.
yeah,
Okay, I'm a little confused, but that's okay. I wasn't there.
that was the project.
Sure. Um, Massive data management is a lot of fun too. It's like all of that plus all the NoSQL stuff as well, which is really cool. Um, I like this one a lot. I've actually got a chance to teach it once, which is nice. But now they got one of the smart tenure track guys teaching it who actually researches in this area, so he's much better at it. But these are the fun ones. So
Oh,
if you haven't taken these,
because that was for operating system.
oh, okay.
I was the one.
Oh, no worries then. Okay. So no one had 421. That's okay. So you ideally you'd be bored if you took 421 because you learned everything about databases already. So this will be slightly more interesting because you haven't heard it before. Sort of the idea here. So I'm going to start with Excel for fun. Now, the idea with a database is we're storing information in tables, right? And what we get is we get columns that we specify. So if we wanted a table for student, right, all of the attributes of student become columns. So it fits very naturally with the way we've done object-oriented programming, but it takes a couple extra steps, and I'll show you some of those extra steps, okay? So if we think about a student object here and what sort of attributes we'd have for student, you probably have like or an ID number, right? You all have a unique ID number, your UMISH ID or something like that, UMID here. You've got a name, a major, yep. Um, graduation. Like an expected graduation year? Yeah. Sure, expected grad year. GPA. GPA, yeah, that's something we could put here. Again, we'll talk about that. So that's a good example here. But we've said here's some attributes. Right? These are things about student that we probably know. Right? So these define our columns, and each of these in a database we say what type of data is it. Right? Just like we get to have strings and floats and doubles and all sorts of things, you get all sorts of types in your database. Right? So an ID number is probably an integer. I don't think you guys have decimal places in your ID numbers.
Yeah.
Right? Um, name is probably a string, right? Major is probably a string. Grad year could be an integer, could be a string, like depending on how you wanted to handle that, you could do it multiple ways. There's actually a date object if you wanted. You could have a specific date in there as well. Just like Java has a date object, SQL has date objects as well. Up to you. And then GPA is probably a floating point or double, right? Probably don't want that to be an integer, right? So you'd specify what type of data all of these are. Now, when we start talking about SQLite, it has a very limited set of types. Enterprise databases have much more types, many more types. I can't talk here. So we have our columns, which specify all the attributes. And then we have rows, which has lots of different terms here. Some people call them entities, right? Make up a row. I just like instance. Again, that fits the object-oriented language. So every instance of a student has data in all these rows, right? So we've got, hey, student 123 is Eric. Major was the engineering program was going to be 2027, and I think I had like a 3.7 or something for my GPA. Um, sure. So that's one instance, right? One entity in the student table, right? And we can have more than one student, right? We can start filling out as many of these as we want here as we go. We just start giving them values. Now, in database land, if you don't know if there's a value, you can use null if you've specified that's allowable in your table. So when we create these things, you can say in your database, this field cannot be null. You must give it a value, which depending on what kind of attribute it is very nice, right? It's pretty handy. Maybe I should put Eric Chemesky here, right? So you can do things like that. Now, problems we're going to run into is if you want to do something like, hey, I want to sort by someone's name here, you probably don't want to sort off their first name, right? Most lists of people we sort by last name, right? And having your name in a single field gets to be problematic. So what we tend to do in database land is we want to separate things out. There's a rule here, and you can talk more about it here. It's database normalization. There's all sorts of fun. I could talk about it for hours because I happen to enjoy that sort of nonsense. And it's every field should only have a single value is one of the rules when you normalize your tables. Right? So I shouldn't have multi-valued fields. So for name, this is not a good column here. It's not a good attribute. So what I really want is I want first name and I want last name. Right? I can be specific here. Now, if I want to sort, I can sort just on the last name field. Right? It makes this a lot easier for me, these sorts of things. Okay. And we'll call this one, this is student here. Right. Excuse me. Now, let's add a list of, how about we do courses? Yeah.
Should we do the same thing with major, for instance? Because these like doctors,
Yeah.
yeah. So should it be maybe degree type and then field? So like degree type would be doctorate, and then
So you could, yeah, so you can add in lots of other types and data about majors. And we can get more specific about that in just a little bit, and I'll show you how we can add in all those connections here. Um, we'll go out to courses next, and then we'll look at that. So a given course then, right, is defined in our catalog, like CIS 412, Introduction to Quantum Computing. That sounds very exciting here. I think that's new. You can't receive credit. Oh yeah, that's a graduate split class. Cool. Um, so we probably have a course number, right? Course number that also has like the department as well, right? And again, we don't want to have separate or like combined fields here, right? Because if I want to find all the CIS courses, I'm going to filter just on CIS and not have to look at the numbers, right? So you have like a department and the number then. So we also have a department and then the course number. And then when we have like title and then the description and then like the credits, right? How many credits it is. So CIS 421 database management systems description. That's some long description here. That's we'll find, and that's what a 4 credit class. Very exciting, right? And we might have CIS 296, right? Java programming, long description here, or 3-credit class, right? And so on and so on. So we can have all these details here, right? So that defines what the course is. Now, how do I say who's teaching this course and what semester? And how do I know what students are enrolled in any of these courses here? We have to have more information here. So each of these courses can have multiple sections, right? Every time it's being taught, there's another section, I think is our terminology for that. So we can add a section table here. Now, section has to have a course, right? Because you have a section of a course. So these are related. This is what we call these relational database management systems. There's relations between these tables here. So what we don't want to do is say, hey, here's the course name or course department. Here's the course number. Here's the course title, right? Here's the course credits. And then we get the section, I don't know, semester, and then the section, right? You can see this is going to be problematic pretty quickly here, right? Because then I'm going to have duplicate data. Right? I'm going to have CIS and 296 and Java programming. And every time we offer this, every semester, I'm going to have the same information again. Right? And it's duplicate. So one of the things we want to avoid is having duplicate data. We don't need to have duplicate data. What we were going to do is we're going to reference that information in another table. Say, hey, I already have all of it. It's over there. Right? Just like our Monopoly game. Hey, here's my owner. It's in this instance the owner. Right? We can reference another object from an object. So it works very similarly with our object-oriented programming. So we don't need any of that course information here. All we need is some unique identifier to go look it up in the course table. So we get another fun technical term here. We have a primary key. So a primary key is the primary unique identifier for a given row in a table, for a given instance, for a given entity in that table. So how would you uniquely identify a course? Well, it's the department and number, right? So you can be more than one here. For student, you would uniquely identify your student with your ID number, right? Just a single field. That's the most common. You just have a single ID number. That works out really nice. Course, you can have a combination. It's called a composite key. There's more than one item. You can combining them here. You can do that as well. Or we could add in another field here and have the course ID here. And just say this is like 1, 2, 3, 4, whatever here. The number doesn't need to matter, but it becomes a unique identifier that's easy to reference somewhere else. Right? So we can do it like that if we want. So section might have a course ID. Now, in another table, it's not known as a primary key. This is known as the foreign key. It's a key foreign to this table. It's some other table's key. Right? So this is our foreign key. So hey, for course number 1 in fall 2025 here, this is now just semester, right, for the section here. And then what else do we want to know? Like the day and time, right? Day, time, yeah, instructor. Now, do they want to list all of my information here, or do they want to go get my information from another table? Right, so it's probably the instructor's ID. Right, so we probably need a table for instructor. Right, that has an ID and it has a name. I don't know, title, anything we want here. Right, so yep, yeah, department. So I can have Eric Charneski here. Again, we could do first name and last name and do all those other sorts of things here. Field lecturer 2, CIS. Great. So then section would say, hey, go find instructor ID 1. That's the instructor who's teaching this one here. This is Thursday, 6 p.m. or what, like start time and end time. If you want to make it specific, start time and end time. Oh my goodness, I can't spell time. I can't type time. Sorry, that's a little small. I can zoom in a little bit for you. Start time and end time. So what, 8:45 p.m. Sure. Anyway, we want to store this information, we can, right? So if it's a foreign key, to go get that information, we just go look it up from another table. We have a relation, we relate. So what you're able to do when you create databases in database management systems, you can define something known as a constraint. You can say, hey, this has to exist. I can't give you a foreign key that doesn't exist, which makes a lot of sense. It maintains the integrity of our data. You can't give me a course ID that I don't have in the course table. Right? If someone is manually entering this stuff and they type in 277 and there is no course number 277, the database will puke on it and say, no, that's invalid. And the database itself will stop you from entering that data. Our application has to handle that, right, in the form of an exception. So the database will throw an exception, or our tool that connects to the database will throw an exception. Our code will have to handle it, right? But that sort of thing. We want it to maintain that's called referential integrity, right? If it references something, it has to exist, right? And that's how databases maintain their integrity. They can enforce referential integrity. So they do these sorts of checks as we're adding data, which is really cool to make sure we don't get bad data. Now, one of the sad truths of life is most of the people who do data entry aren't paid very well, and they just don't really care, right? If you ever go to a hospital and you've been there before, you probably have a medical record at that hospital, right? But the person who's admitting you, like the admissions clerk in the emergency room, they don't care. They're like, "What's your name?" Look you up. "Oh, you don't exist. I'll make a new record for you," because they typoed your name. And now, when you go back in the ER, they're not going to have your whole list of allergies that you already had before, or whatever previous medical history they needed to be able to better diagnose you here. So, ensuring we get good referential integrity at our application level is very important because people just don't care, right? Sadly, they're not paid enough to care, and that's sort of true, right? You would like them to care about good data going in, but they don't always. We get all sorts of things like that. Anytime people do data entry, it's just not a very good paying job. So they tend not to care. So enforcing integrity is a very important role of the database. All right. So the next thing we have then, how do we put students into a section? Do I have like the student ID? Right? Because you've got a unique ID here for a student. Can I just put a student ID here? Here's student 123. Well, how do I enroll a second student?
Say that again.
So how would I add a second student to this section? Okay, student 123 is taking this section. You're enrolled here. Can I add another one? Should I just comma separate student 234?
Should I do tab?
Another field? Or another table?
Yeah, like on the tab.
Yeah. Oh, yeah, another tab. Yep, sorry, tab. Yeah, so we can't reference a single student here because more than one student takes a section. So when we start talking about relations here, you can define relations with there's a one-to-one relationship. One instructor works for one department. That's not entirely true, but sure, we'll just pretend like that's true, right? It's a one-to-one relationship, right? But one department can have many instructors, right? So going one direction, one instructor, one department, but going from the department, it'll have many instructors, right? One course will have many sections, but one section relates to one course. So the side that has many is the one that's going to relate to the one, right? So section has one course because it relates to one course, right? So course doesn't have the list of sections. It doesn't have the many sections in the course table, right? It just has multiple entries in the section table. Each of those entries relates to one course.
Is that like when you see the graphs and you have arrows?
Yeah. Yeah, so you can use like crow's foot notation, and there's all sorts of ways we can do graphing for these, or UML documentation for databases. It's a lot of fun. Now, the problem gets to be when we have many to many. Right? There are many students who take many sections, and many sections have many students. Right? So what you have to do, if you have a many-to-many relationship, we can't solve that because I can't put a list of students in section, and I can't put a list of sections in student. We can't have multi-valued fields. It's a bad idea. Right? And then it just gets to be a giant mess here. Like, how do you find who's on what section? Well, then I have to go to student and look at all the sections and read through all 45 sections that you guys take before you get a degree. Right? That's sort of nonsense. We add a joining table here. So we'll add, a lot of times, this is like the enrollment table. So what's the verb here? You've enrolled here. Again, it's okay. So this will have a student ID. It'll have a section ID. And then we probably have what your grade is, right? You might have other information that you get from this, right? And this is probably where we're going to record your grade, right? For this student, for this section, here's the grade they got, right? So here, student 123, section number 1, grade, we don't have it yet. So this might be nullable because I don't know what your grade is yet. You haven't passed the class yet or failed the class yet, right? But at some point, we'll put something here, right? So maybe this one's nullable. And we just say, okay, now for this section number 1, now we have student 2, 3, 4. For section number 1, we have student 3, 4, 5. So I can have many students for one section, and student 1, 2, 3 can also take section 2. And student 1, 2, 3 can take section number 3. Right? One student can have many sections. We just get multiple entries here. So if I want to get a list of what classes has this student taken, I search by student. If I want to get a list of who's in this class, I search by section. Right? Because that has the many relationship. So now we have one student has many enrollments, right? But each enrollment relates to one student, and one section has many enrollments, but each enrollment relates to one section. Right? So we can take that many relationship and solve it, implement it with a joining table here. So this is going to be very common anytime we have many to many relationships, and there's a lot of them. Those happen very often here. The common example is when we sell things, right? A store selling something here, you can buy multiple things, right? So your order will have many items, and an item can be bought by many people, right? So we have a many to many table. So you have like the order item here. So for order number 1, 2, 3, it has item 1, item 2, item 3, item 27, item 59, whatever it happens to be here, right? You can list all of that out in the joining table with multiple entries. So that's another common example here. And then we can have additional information about that, which is really cool here. And that's very important when you start talking about orders and sale prices and things. When you bought it, it has a given price here. But I can go change the price of what I sell this item for somewhere else, and I don't want it to change your receipt, right? Because your receipt should be fixed. So if this item goes on sale later, I'll know, hey, you bought it for $20. Now I'm selling it for $15, right? Without have changed your receipt. So you can add additional things here, which is really nice in these joining tables to have that additional information, which is nice. And then if you go return an item, if it was on sale and they jacked the price back up, when you go return it, they're not going to give you that full price back. They'll be like, I'm going to give you the price you paid for it back, right? So it's important to store that kind of information here. Um, so we've got enrollment, we got student, we got course, we got section, we got instructor, right? All sorts of pieces of information we can collect and store in this relational database here to be able to give us this big picture, right? And then somewhere in here, we probably have a degree with a list of required courses, right? And then like, here's your degree would link that way. I know what the degree is and I know what courses you have to take. So I can go get the list of courses you have taken. I can get the list of courses you need to take. And degree work says, hey, you have to take these 3 more courses to graduate because you kind of want to get your piece of paper at the end of all of this, right? Otherwise, why are you here?
So we would have like a major ID,
Yeah.
major tab
Mhm.
that has all those. Like we have all those many.
Lots of relations. Yep.
Yeah, how do you begin like querying them?
That's what we'll start doing here. We'll do it in code, which is a lot of fun. But yeah, so it's you just start defining those relations and you connect them as you're doing your queries. And we can do all those here in a little bit. So that'll be fun. So we'll go build all this out. Why don't we take a break? It's a little after 7 now. We'll come back. I'll show you SQLite and we'll start building this out in SQLite so that it exists and we're ready to use it in our application. And then we'll do the application side of things and build out a little demo app for you. Okay.
It's just like your SQL.
Yeah. So the one there's a couple different approaches, but the one approach is you just write SQL in Java and say run this. There's more friendly approaches that are object relational ORMs. What does ORM stand for?
Like SQL is pretty much altering data, querying data, right?
Yeah, creating, reading, updating, deleting. So ORMs are object relational mappings. It's essentially taking code and relating it to my database so I can work with it like it was code, which is really fun.
Is it similar to Python?
So it's just like a library. So Java ORM. There's a couple ones out there. Excuse me. Yeah, like this one is a little bit nicer. So you can do code related things. This had a fun example. Where'd it go? So instead of having to write the SQL query, you can do this in your Java code. It essentially translates from code to SQL, which is a lot of fun. That's Juke, apparently. I'm the creator of Juke, so it's biased, of course. um, yeah, there's a lot of ones out there, and different companies will use different ones here. don't. We might try this next week here. We don't think we'll have time to try it this week. Do all the mappings here, but it just work out. Doing the SQL is not too bad. It just you got to get used to SQL for a little bit here. All right, so let me pause this. Here. All right. So the book uses this SQLite DB browser tool, which is a free open source tool. It's pretty good. There's a lot of different flavors of SQLite browsers out there. You can use any of them. I usually use one that's a VS Code plugin, but this one works too. And we'll just use this because the book has all the same examples with it as well. So you can just go download it here, and you can use the installer or just the standalone. Hey, it's ready to go. The zip is fine. If you just want to be able to quick run on it, that works out pretty well. Um, and I think it should work for you no matter what permissions you need, but should work pretty well. Oh yeah, it's a portable app. It's a fun portable app here. Come on. Is it going to open? Maybe. There it goes. So just unzip that and just leave it in downloads for right now. Because oh look, I've already downloaded it before. That's copy number 1. And then you can just run SQL browser here, or DB browser for SQLite. And this gives you a nice little visual interactive tool for working with a SQLite database. Okay, so we want to make a new database, and now I'm going to put this in my repository folder. Right, so I'm going to make my file in this location, just like we do with our projects here. So this is our week 9 or Java, and then let's call this one what, college or something. We'll call it our college database. And now we get to say, okay, what's your first table? So if you like SQL, you can actually write the SQL commands here. If you don't like SQL, that's okay. You can still do all your click, drag, and drop with a nice little interface here. So as you get more familiar with SQL, you might prefer the SQL. And if not, that's okay. We've got our options here. So these are our fields or our columns here. And say, hey, here is our ID here. And then of the types, you get integers, you get text here, which is like a string type. You get blobs, which is just blob data. It's a large binary piece of data, essentially. So anything you want to store in binary type here. And then you have real and numeric. I think real is like real numbers. Numeric is numbers with decimal places. This is usually the easy one here. I don't actually remember what the real type is here. Hang on, let's SQLite data types. I think the book has it too. Real. Where was numeric? So floating point number says real. Okay. SQL data types. Huh. Okay, so it doesn't say numeric. I thought we used numeric. So we use real, I guess. That's fine. I don't think we had any decimal. We did for GPA. Was going to have a decimal place. So integer type. And then it's got a couple options here of things we can check. Not null, right, is the NN. So if you should not be allowed to put a null in this field, you check the box, say it's not null. If it is the primary key, say, hey, this is the primary key, and primary keys should not be null, right? Because you can't have something there without its identifier. Auto increment is a really handy tool to say, I don't need to tell you what the ID is. You, database, keep track of the next number. And it will just keep track. Starting at number 1, every time you add a row, add another entity, add another instance, it will add the next number. So you don't have to define what student ID is. It'll just grab the next one in the database. And the database will remember, oh, okay, I'm at number 27. The next time you add something, it'll be 28 or 29. So this is very handy for primary keys that are just numeric ID numbers, because then you don't have to worry about what the number is. You can just add all the other pieces of information here, and the database will tell you what that unique identifier is. And it will always be unique, which is really nice. So I'm a big fan of auto increments here. And then you can also add a unique constraint that is separate from being the primary key. I didn't specify that, but a primary key has to be unique, which I think makes a lot of sense, where you can't have 2 entries with the same number, right? Because that's not allowed. But other fields can be set as unique. So you might have in your student database, hey, here's your student ID number, and you might also have a social security number. That social security number should be unique, and the database should puke on anyone who tries to add a duplicate. Right? At the database level, that's a bad thing, because that should be a unique identifier. right? So however you want to do that, you can specify those sort of constraints at the database level if you want. You can add default values and say, if you don't tell me what the value is, I'll just assume it's blank or assume it's a 27 or whatever values you want here. You can add other checks and collation stuff, other fun things. It's pretty cool. You can specify as a foreign key as we're building. Here's the other table this relates to, right? So we'll get to that as we build out our other tables. But student doesn't have a foreign key yet, right? So we just have our student ID, and then we have a so primary keys are automatically unique.
Oh,
Then we'll have what first name here, and that is text, not null, right? And then we'll have a last name as text and not null. And what else do we have here? We said a major and GPA. Major. We'll just do as text for now. You could go relate those things later. Uh, you might not have a major, right? Maybe that's null for now. Maybe you just start with it undecided. Now, you probably have a field in your majors list that says undecided. Again, so we would relate it eventually, but for now, that's probably fine if you want to leave that null. Not going to be too bad here. And let's do GPA as a real number here. Now, if you just started, you don't have a GPA, so it's probably okay to be null. Eventually, you'll get a GPA. And the other fun thing is well, you probably don't want a zero GPA unless like otherwise, right? I think zero is probably a bad default.
I think university actually does that.
Really?
Yeah.
Oh, that's really sad.
University match tells you.
Oh, okay. That's sad looking.
Yeah.
I think null's easier, but sure. I mean, handling nulls can be awkward in code, so sometimes it's nice to have defaults here, but that's okay. So this is the code we would type in SQL, and we hit OK, and it actually runs that SQL for us. Oh, we need table names. This is student. Here we go. Student. So create table student. So this, if you like your technical terms here, this is EDL, data definition language SQL commands. So it's all SQL, but this is the data definition to define tables. So there's data definition language and there's data manipulation language. So DDL and DML for fun technical terms. I'm sure you'll get to in your database course eventually here. We're defining data, we're not manipulating data. So all the create, read, update, and delete, those CRUD operations, that's all data manipulation. You go get the data out, but it's not defining the tables. And some of the fun things with enterprise database management systems, you can give specific permissions to people. So like right now, we can do anything and everything to this database, and my application can do anything and everything to this. There's no ability to restrict. In an enterprise database management system, you can say this user can only do create, read, update, delete. They can't do any of this data definition stuff, which is probably a good thing because you can really screw stuff up if you run the wrong commands here. Or if you're using, was it Cursor, and it has access to your production database, it can go drop your production database if you're being an idiot vibe coder, right? That was in the news lately and made me chuckle. Definitely didn't feel good that we're smarter than computers at all. But you're able to restrict user access in an enterprise level database, which is nice. So all right, so we got that table. So we have our list of table here. Now it also has this SQLite sequence. That's where it's tracking the next ID number, essentially. So like we get this table by default, but the data that the database uses is also stored in the database, which is kind of cool. So you can go get that information out, like, hey, what's the next value going to be? In case you were curious, you can get that info out. So we got student, and then we were going to have course. Right, course would have a ID number as an integer as the primary key, auto increment, not null, and then it had a department, which was text. That was not null, and it had a course number, right, which is slightly different than the ID. That's an integer value. I think they're all integers. And then we had a title, integer value, and we had credits. Right? It also had description, but we don't need to care about description right now. Right? The title is probably enough. None of those should be null to have a course. Right? So here's our SQL for that. Works out pretty quickly here. Student and course, and then we're going to have section. Oh, I'm sorry, we need a instructor first, right? Or maybe a faculty table. We can sound fancy here. So we just have an ID number, not null, primary key, auto increment, probably fine. The first one is number one, the next one is number two, that sort of thing. We'll have a name. Now, first name and last name is probably better, right? First name and last name. Oh, I shouldn't have had spaces in here, sorry. Spaces are usually ugly when we're dealing with databases. Not null, great. A last name. Oh, as text, not null. Um, do we need anything else? Department, I think we had department. That was as text as well. Sure, that's probably fine for faculty. Right. Let me go back to student. Right. We wanted first name. We edit.
Maybe for faculty, we should have like a classroom they teach.
Well, so that'll link to the sections. Right. Uh, oh shoot! I wanted to modify, but that's not. It wants me to save it first. Save. Sure. First name. Take out the space here, and last name. Take out the space. There we go. That's a little more proper. All right. So we got the, and then we need section. So section had a ID here, just its unique ID is fine, right? Primary key, auto increment. And then we had a course ID, and this is not null, and this is a foreign key. So we're going to say, hey, this is a foreign key to the course table, the ID field. Okay. Now, this one here, oh goodness, SQLite gives you some bad defaults. Um, it don't worry too much about it, but enterprise databases are much nicer. Um, what do you want to have happen if the table this references gets updated or deleted? Um, Deletions should not happen. And that gets to be all sorts of trouble here, but you shouldn't be able to delete a course if it's referenced by section. And you don't want all the sections to go away if you try and delete the course, right? Because that would be a really bad thing to just delete a bunch of data out of there. Right? You probably never delete. So again, depending on your databases, some databases you do delete information, but you never want this on delete cascade option here to happen. It's just a bad default. So course ID, and then we had faculty ID, right? As an integer, not null. This one's a foreign key to the faculty table, the ID field. Oh, what happened up here? Did I lose it? This was course and ID. Okay, there it goes. So references, here's the table, here's the column. So you can do it all by hand, right? This foreign key for in my table references this table, this field. This my field references this table, this field. That's all how that's all defined here. And then I also think we had a grade, right? And that one we said was nullable for now. That was just text, right? A, B, C, D, whatever here. If you wanted to use the numeric types, it might be even easier. Like, hey, you got a 3.7, right? As a B plus or something like that, but or A minus.
Also,
What?
yeah, shouldn't the grade be between the student and the section?
Oh yeah, not the section. I'm sorry. Yep, yep. I got yeah. That's enrollment. My bad. So remove that one. Thank you. Yes, we just had this, and then what do we have? A semester, right?
Like end time or start time?
Yeah, yeah, yeah. Thank you, thank you. Text. I'm forgetting which one I was working on here. Semester, and then start the day. Right, is text. And this gets to be fun if it's online because there's no day or start or end time, but that's fine. Start time.
You should also do like a teaching mode, which can be hybrid or
Yeah,
is that
yeah. You can add all sorts of fun options here, and it gets to be complex somewhat quickly here. But for now, we'll just pretend like they all have days, start, and ends. If you want to live them be nullables for online ones, that's cool too, I suppose. I guess we let those be null. Um, that's fine. Was that modality or something? We can have that modality as a text, or maybe you have a list of I don't know how you want to manage that. So we got this is kind of a big table, but this is the section here. Got that one here, and now we had enrollment. So that was our joining table for students to enroll in sections here. So this was enrollment. And again, like when we define classes, these tend to be nouns, right? With a bunch of attributes. So the way we design object-oriented programming is very similar to how we define relational databases. Not exactly, but it follows generally pretty well here. So enrollment, then we just had, here's the ID, which is nice and easy as a auto increment primary key. And then we had a section ID as an integer, not null as a foreign key to the section table ID field, right? And then we had a student ID to the student table ID field, right? That one's not null. And then we had grade here. So my grade was text. Wow, the padding is off here. Text. There we go. And again, not null. Null is probably blank until we know otherwise. That's fine. Um, I guess technically, if you drop a course, you don't get a grade for it. So maybe it's fine to have a null here because you might be able to drop them. We still want to have recorded that you attempted the course. That sort of thing. Like how managing our data gets to be tricky, right? And those rules have to get translated into the database. And it gets to be fun stuff here. But now we've built it out here. So we should be able to go and save our database. Save all. Okay, so now we should have it here. Now you can browse data. So this was the structure here, and then you can browse the data and start adding stuff for these fields if you want here, right? This is all really nice here. Or we can go build out a program that lets us go and modify some of this data here, which is fun as well. So we can go run the SQL commands to create, read, update, and delete. Those are our CRUD operations. Right? It's inserting data, it's creating data. Updating data is updating data, deleting is deleting, and then reading is known as select in SQL. Let's say select here so we can do our different operations. So we can do them here. Do you want to do a graphical project with Java FX and have little drop downs and buttons and things? That's a lot prettier, right, than console based? Or should we just do console? Okay, that's fine. Let me leave all this. I'll just comment it out for now. I don't want it all here. Um, so we need import java dot.
It's gonna be a group project, right?
It can be. This one doesn't have to be, but I would recommend you do your group of three for who you want to work on the final project with, because the final project does need to be a group project.
Can we choose whether we want to just like the terminal or?
Yeah, that's fine. Yeah, either way is okay. All right, so there's our SQLite. Now we want our database driver here. So the database driver is the connection here. So JDBC, Java Database Connection, is our common one. It uses the pretty common API for these. So you can download different drivers. I think SQLite just works here. Yeah, you can go get a bunch of different ones here. Oh, it is? Okay. We need the one for SQLite. Really? Okay, that's fine. So we need to go and add that to our project. So we go to our project structure and we want some libraries. We're going to go add a library from Maven. We'll go automatically download this for us here. So we want SQLite, and it should go search here. Search. And which one did they recommend? I forgot already. Xerial SQLite. Oh my goodness. There's too many of these here. Xerial. Xerial. SQLite. Okay. And look how many different versions they have. Oh my goodness. Probably the latest is probably the good one, right? For SQLite. So Maven is the tool, is a package manager tool that says, I'll go out and download this package for you. You don't have to go download the jar files yourselves and add them to your own libraries and all those sorts of things. This is what made doing Java FX projects a lot faster for us because it hooked up all these downloads for us, which is really nice. So we'll go download this one. Say, sure, I want the library. I'm going to add it to this module. And now it goes and adds in these. So you can go manually download them yourself and go reference them. It's just a small pain, right? And then everyone has to go do it, right? So it's nice and easy if we just do that one itself here. All right. So we did that one. And yeah, he shows you how to do it in NetBeans or Eclipse. It's just that much easier here. So you would download the SQLite JDBC jar file. We don't need to go do that, which is fine. So now we can go and use our driver. We just got to go import it. Back to our database. So with SQLite databases, you just point it at it. With actual enterprise databases, you tell it, here's my login information. So it gets a little bit trickier as you go here. So for us, we just say, here's where my file is, which is really nice. So we can go get our connection. We'll just steal this one here. Copy. We'll come back to the import in a second here. So let's go start adding some imports. Java.SQL. There we go. Java.SQL. Connection from Java SQL. Come on. Uh, and driver manager. So we want SQLite. Ours is not products. Ours was college, not SQLite. And that was the name of the file. It was college.SQLite. And this is just a relative path here. Right? We don't want to give an absolute path. If you use a database, or a enterprise database system, you tell it, here's the server name and here's the port you connect on, all sorts of other information like how you get to it over the network. Most of the time you don't run local database servers for development. It's nice and easy, but usually they'll tell you where it lives. And what's the issue here? Not supported. Really? Oh, I put that needs to go in here. Put it in the wrong spot. Okay, there. Now it's a little happier. I put it in the right location. So we should be able to go connect to it. So this gives us the connection here to our SQL database management or our SQLite file. And we can go and do things in main with it here. Okay. So yeah, MySQL, right? Here's the server name, port number. So if you're running it locally, and there's a nice little development one you can download is good. That one's fine. Now, when we use our connections here, we're executing a query, and it gives you essentially this result set, and it uses a cursor, so we're not loading everything all at once, because databases can have lots of information out there. Right? You might not want to try and load all of it into memory all at once. So what it does is it uses a cursor to say, this is where the next piece of data to read is, then I'll go read it. Right? And it sort of lets you iterate through it without getting all of the data back, which is really nice. So you can go next, and then eventually we'll go close our connection when we're done. So we get some connection here with multiple rows. We want that one here. And then we'll loop through. So let's go steal this one. Goodness. Yeah, just import star. Goodness, SQL star. Why do I do them all by hand? That's obnoxious. All right. So this is we got to get the connection here. So our connection connection equals get connection.
So is that an API?
So the library that we're using, the Java SQL JDBC stuff, is the API that we interact with. And the jar, the SQLite driver, is the one that says, okay, if you're using this here, I'll do the translations to work with SQLite. This needs to be static. So I can use it here. Get connection. No? Oh, add the exceptions. So bad stuff can happen here. So we'll just add a try block. Anytime we're working with SQL, exceptions can happen. So let's do try catch. Put all of this in the try. You get SQL exceptions. Bad stuff happens. I don't want to throw a new runtime exception. We'll just print message. Okay. So to run our queries, we give it a SQL command. So select is to read data. So selecting star, we don't have a product table. We had a student table. Do that. So star says everything. So give me all of the pieces of information from the student table here. And then we want to loop over and iterate, right? And go and get that information. So as long as we have information here, let's go loop over and print it. No, all products next. And then close. So we wanted to spit out something here, right, when we're done. We shouldn't call this products, we'll call this one students. Let me go rename this one here. Go rename students. So as long as there is more to read, we'll go and do something here. Now, again, this suggestion is not great here. This is, but you get individual fields out by name or by index. So by name is preferred. So if I know the name of the column, the name of the field, here I can go get that information out, and you have get string or get int or get. So you've got a couple different options for our gets here. So students get. So you can go by the index notation, but that's not great if you're doing a select star, because your database structure could change. If someone adds another column somewhere, it's going to mess up your ordering. So by name is usually preferred with these ones here. Now it's possible they could rename their columns, but that's more of a breaking change. People don't do that all that often here. So we want to get some piece of information here. So like a get string. Um, let's do a get int, right? Because that was our from the ID field, right? And we'll just print that out, I guess. So student. Um, so we want to go get the integer from this column, right? That's looping through the result set. I think I missed one because we want to get the individual row. Let's go steal that one here. Products. No, get. Okay, so if we have our own classes here, we go get those values, turn them back into classes so we can interact with them. We'll get to that in a little bit. It's like building your own mapper. Takes a little bit of time. Let's just see if we can get the ID out here. So I'm going to go and browse data for students here. And let's go add a new student. When I go, this one, add a row. No, that wasn't it. Student. Goodness. No, not course. Where's my button? I don't use this one very often here. I want to go add. Oh my goodness. Browsing the data. Oh, it's just browsing. It's not letting me edit. I want to go add. Well, that's fun. Did they sell? No. Wow, that's obnoxious. Edit. Where do I go edit here? I don't want it to do it by hand. Really? Okay, I guess we gotta go edit by hand. We're not gonna find any right now because there's no data at the moment here. So if we want to go add some information, let's go add. Should we add a little menu? Goodness, connect not connection. Why? So let's go read out our students. We will add a little menu for for the choice. Enter 1 to add, 2 to read, and choice can equal. Oh, we need our scanner. A new scanner given in, and then choice can be my integer %. There we go. Keyboard next line. We'll get our choice, and if choice equals 2 for reading here, we'll do all this stuff here. There we go. So if my choice equals 1, else if my choice is 2. Okay, we'll go do this. So I guess we want the connection. Oh, that's fine. Why? We need a try block. Oh my goodness. All right, let's round with the try block. Try. And then we'll go steal this catch. All right, try and catch there. So we're not selecting from student, we're going to insert into student. So we're going to say insert into student. Now, with our insert statement, because we have the auto increment for ID, we don't need to give it ID. And if you're not giving it every field, you need to specify what field you are giving it. So we're going to say, I'm going to give you a first name, a last name, a major, and a GPA, right? For our insert here. So we'll say I want to insert into student, and then in parentheses, we say first name, last name, I forgot already, major and GPA, right? And then we tell it the values we're going to add. In parentheses, we give it that list. So let's add Eric Chernesky, EENG, and 3.7. Oh, look, Chernesky spelled wrong. Oh, okay, so that should go insert into student. And is it execute? I think we want execute. I think we just give it an execute because we're not doing a query, right? Is it? Nope, never mind. All right, execute query. Sure. This should have been the string. Oh yeah, we don't get a result set. We just get a um, Boolean result. So it's going to be true if it worked, false if it failed. We're never going to really use it here. That's fine. So it should go add it. And then when we're done, we want to close that connection. Close. So same like with when we do files, you open it, you read or write it, and you close it. We're going to close our connection down so that we can get to it later. I'm pretty sure with SQLite, you only get one connection at a time. Enterprise database management systems can handle more than one connection. They're a little bit nicer, these sorts of things here. But eventually we should be able to get Eric out here. Or we could go ask for that information, right? Would that be more fun? Go ask for that information. Get a string for first name, a string for last name, a string for major string, goodness, major, and a double for GPA. Enter first name, last name, major, GPA, and a string for text, keyboard.next line. Yeah.
Or when you actually use this approach at all?
Yeah.
Yeah.
So usually the mapping, the tool we'll look at next week, is preferred because it's a little easier than doing it by hand. But for small little things, doing the mapping is a little overkill. Right? If you just have a couple tables, you don't necessarily need to go through all that work. Um, it makes life easier. It's more setup time because we have to build out a class that matches each one of these with all the attributes that match. So if we build out all the classes that match, it says essentially we can read them in and then turn them into objects, or we can update the object and write an object. So it's a little more natural to work with in code. Um, it just takes, I don't know, a little bit of setup involved. So if you know the SQL, this is pretty quick to just do the SQL. So then if we want then to split that results here, so here's our string, we can use our split here. So here's the split is text split on a comma, right? If we comma separate those things here, then my first name is the split of 0, my last name is split of 1, my major is the split of 2, and GPA is, oh, look at that, split of 3. That was so nice. I love those suggestions here. Then we can go through and substitute in here, right, all of our values. Now, anytime you're dealing with user input, it's really ugly to just take the input and throw it into the string with string concatenation. I don't know if SQLite input sanitization. Don't know if that works here. Other tools do it. So someone can enter bad things that can do bad stuff to your database if you just drop it in here. Okay, prepared statements. There we go. So we're going to use a prepared statement. So that will do as substitutions here. There we go. So prepared statement, let's steal this one here, will help avoid any of those issues here. So instead of just right out executing the statement, we're going to make a prepared statement. Connection dot prepare the statement, and then we can give it our commands and substitute data in here. This was insert into. Let me back this out. So it's just one line here. And grab all that. So we use question marks to have where these things are being substituted in. Let me say question mark, question mark, question mark, question mark. So then we can go and substitute those values in here. Here's our prepared statement. Sure. Prepared statement. And we can go and set values, which index and what value. So set string for 1 is first name. For some reason, this starts at 1, and I don't know why. First parameter is 1. This is the saddest thing I've ever seen because everything should start counting at 0. But for some reason, it starts at 1. First value is index 1. It's okay to cry. That's the weirdest thing here. And 2 then is my last name. That's a set string again, prepared statement, set 3 for major, and then set double 4 for GPA. Look at that. It knew. Awesome. And then we can run the prepared statement. Prepared statement dot execute here. And it will give us back a true or false. It should be fine here. We know if you need to save that Boolean result. We're not really doing anything with it here. But we should go ask them for a bunch of info here, get it out, try and put it in and see if it works. Right. And then all of this, maybe like 3 to quit. To quit here. We'll do while choice does not equal 3. Do all this fun stuff here. And then prompt them again, right? Should we try it? See if it works on the first try. I'll be amazed. Usually there's typos. Anytime you're dealing with SQL, it's really easy to have typos, and then you have to look at what your SQL exception is. All right, so let's go add a row here. Oh no, failed to load.
What was that mean?
It didn't like our. Is that just the logger? Static logger? That's okay. Maybe that's okay. Warning. Oh, let's see if it keeps going here. So we'll try it. Eric Chernesky, DENG 3.7. Ah, yeah, missing database, incomplete input. Shoot. So it couldn't find the database when we got our connection here. That's a bummer. Oh, that's SQLite. So I'm using the wrong. Driver here. SQLite driver. Using the wrong one. Oh, do we not import it? We have to. No, we did our utilities, right? All right, let me go double check, see what they were doing here. So don't remember. Might just be missing one line here. Prepared statements. Oh yeah, look at that. It's got our prepared statements. Here's the whole code example. Java SQL, SQLite. Yeah, this should just connect. Shoot. Yeah, so he's doing his own like mapping from SQL back to the array list of product. Right? So writing out code that will give you a list of objects. You just go do the mapping yourself. Hey, I'm going to go get these, turn them into a product, add them to my list of products here. So we can go do all that work here. We'll do all of that with ours as soon as I get this running. Why is it not like I've gotten the SQLite to work before? This is really sad. Where did it not connect? Oh, is it just not in the same folder? Yeah, maybe I need to move it. Uh, Show in Explorer. We've got our SQLite file. Oh, it's DB. Oh my goodness. No? College.SQLite? Oh, is this the DB browser? Is that what? Oh, that's the DB browser. Did I not save as? Oh, goodness. Yeah, it's just .db. Let's see if we can change it here. .db. DB. Maybe I'll pick that one up. Hey, okay. We didn't get the error this time. Let's try adding. Oh, there's the error. Jeez. Eric Chernesky, EENG 0.7. Let's see, database. Crap. We've got the database.
When you roll the verb,
Where?
go down. More.
In our one of these commands?
Yeah, right there. Keep going to the right. You forgot to close the brackets here now.
Ah, thank you. Values. Thank you.
That might be.
That's a different error, though. We'll see. Give it a try. Hey,
Okay. Let's go.
look at that. Amazing. Oh, good catch. Bonus point for you. Thank you. Told you, typos all the time. All right. So if we wanted to make a student class then, right, let's go and add a student class, right? And we wanted, what do we have? An ID, int ID, private string for first name, private string, last name, private string for major, and a private double for GPA, private, and then we'll go generate all that other stuff here. Instructors, sure, and getters and setters. Generate getters and setters. And then let's generate a toString so we can print this thing out.
How did you do that again?
Just right click and generate.
Yeah.
Yep. So you just right click and go to generate and pick which thing you want to generate. So as long as you define the attributes first, and then you can generate, and it'll be based off the attributes. So you just have to add these ones first.
That's such a time saver.
Yes. Yeah, this is all boilerplate code. But the toString is going to look pretty nice, right? Again, it's kind of a weird representation, but it's like the JSON notation-ish. That should be fine. Yeah, it'll work out pretty nice for us here. Um, and look, it's even quoting our strings. That's ridiculous. It's adding in the quotes for us. It's amazing. That's so nice. All right, so now I'm going to go read this one here. So we'll go get all these different values and make a student out of it, right? So int ID is this one, get an ID, a string first name. Look at that. I love it. Major, GPA, student equals a new student. There we go. And then we'll just print out the student as well, because that'll give us the nice little output line here. Let's go read them all out. Let's try it. So I should have, now when I browse my data for student, there it is here. Can I edit? Okay, now you can edit here, right? Test? No? Not let me edit? Oh my goodness. That's fine, whatever. But we can see it all. So now let's give it a run. And we should be able to list right away because we've got our database file. Student, ID1, first name, last name, major, GPA, all this fun stuff here. Awesome. So we can go get it out. So what we want to do then is turn this into a method to go get my list of students. Right? We can go get some information from my students here. We can go get information from my list of courses, get information from my list of sections, any of those things here. We just need to turn into some helper methods here. So instead of just dumping all this in main, it's nice to have a little helper class that does all that stuff for you here, right? So we might write a class. So Murrock likes as his database manager class or product DB class, right? That goes and does all that stuff. So if we make a college DB class that does all these things here, right? We'll go and be able to interact with that from here. So we can move all this stuff over to our college DB class here. And this is adding. So we don't need the prepared statement. Execute. Connection closed. Let's move that over. So we want a private, or no, public, Boolean add student. Given a student, right? So it needs to go and get a connection. Nope. Connection, get connection, static, get connection. Come on. Oh goodness, the try block. Try. Yeah. Catch. SQL exception. E. I don't. That's fine. Printing these out is bad here, but that's fine. Why not? All right, and then now we have the student, right? So this is student.get first name, right? Student.get last name, student.get major, and student.get GPA. Right? We can go add those things here to our command, run it, close it. Good stuff here for adding a student. Right? And then we might have a public static array list of type student for get students. Right? And then this one again, we're just going to try. Everything is a try here. Close our connection. So we will steal that code where we go and get all these things here. So we want to have this array list to start here. Well, we got a connection already, so we'll make an array list of type student, students, and we can go add the students here. Students query, I guess, here. I should have done a rename here, that's fine. And then we go add the student, students dot add the student. Cool. Or we could just add it as a one-liner here. And then close the student query when we're done. Eventually, we want to return students. Students. Oh, that needs to exist outside the try block for us to be able to return it. Because it might be empty if something fails. Or ready to be empty anyway here. All right, so we can add a student, we can get a student. So back in here then, we shouldn't need our try catches, which is nice. We still need that information. We don't need our statements. Here, let's do these. First name, last name. Oops. Major and GPA. All right, we don't need the try block. So if it's 1, we want to go get some information here, and then we can call our college DB dot add student, given a new student, given all that info, ID, first name. Oh, we don't have ID. Oh shoot. So the ID doesn't matter. We can just give it 0. First name, last name, major. That should be fine. And if it's 2, then we want a list of students, array list of type student. Students is my college DB. The DB that I get students. And then what for student in students, print out the student. All right. So we can interact with it this way then, right? So we've moved out that code that deals with all the database stuff to the database class, essentially. What is it unhappy with here? Are we missing the right number of parentheses? Curly braces? Catch. Oh, we never returned something here. This should just be void. Sorry. You don't need to do anything here. All right. I think we can go add more as we go. I don't want that one. That's a bad add. Okay. Is it still giving me a red line? Where's the red line? Error. Where's my... No? Oh, it's still running. Goodness. Okay. Come back over to main and see if we can run it now. Oops. Okay, it did have a red line. Too many semicolons. There we go. Okay. Now let's try and run it. And so if we just want to read our students again, not very interesting here, but we get our list of students. I don't know how to make this stop erroring here. That's obnoxious. Failed to load class. I don't think we care. That's fine. We can Google that later. And then we should go add another student, right? So who do you want to add? So I'll add Jeb. Janeski, BS, and no GPA, or you guys 0 to start, right, for now. And then we get 2 students. And they're in our database. So if I come back here and refresh, discard the editor, discard, we can see 2 students in our database file. Okay, I'm going to close this one down, stop this one, let me come over to GitHub here. And now the problem is in 296. In our GitHub repository, we want to make sure that we're going to add our database file. So make sure we just add it. Oh, so we don't need the SQLite one. Let's discard that one. We never use that. We just use the DB file. Okay, we have to make sure that this file is added here. If we don't add this, when someone else tries to use it, if you're working with a partner, they won't have the database file, right? Which is kind of sad. Now, there are cool things. You can make your code generate databases and SQLite files, but you have to know the SQL to do it. So when we're just starting, it's pretty nice to use that SQLite browser tool to build it out by hand because it's all click and drag. If you've done it a lot, you can make code generate the database itself. You're like, hey, if the file doesn't exist, go make one for me, which is pretty cool. And you might even have an option like, hey, do you want to open an existing file or start a new database? And those sorts of things are fun, but that's okay for now. So we go add this one here. So here's our started on College DB and push. All right. So if you've never done databases before, that's a lot. That's okay. A lot of moving pieces here, but essentially we're storing all of this in a database. So it's not just a file-based storage. I mean, SQLite is a file, but with a standard way where we can use SQL queries to go and add information, insert data, select the data. We'll look at updates and deletes as well. If you want to go update a record, we can go get that record to update it here. Ooh, excuse me. So the next one we want to do is to update a student. So we're going to do public static void update student, given a student. Now, the rule with this one here is we shouldn't change the student's ID number because that one's auto-assigned to the database. And if you change that number, all the linking is going to be broken, right? But if a student wants to change their name, sure, that's fine. You just can't go change your UMich ID, right? That sort of makes sense here. Change your name, change your major, that's all fine. Change your GPA every semester when you get your grades, that changes as well. That's great. So what we want to do is we want to do an update command. So we're going to do a similar idea to insert, but it's called an update. So I'm going to steal this one here. And the command just looks a little bit different here. So what we're going to prepare is we're going to say update student. We're going to set, now the syntax gets a little weird. So we're going to say set first name equal to something, last name equal to something, major equal to something, GPA equal to something here. And then we have to specify which record we're updating. We'll say, where the ID equals another something here. So you have to tell me where the ID is. So this where clause in SQL will restrict which record's being updated. You can also have these in selects. If you only want to get one record out, you can do that, and we'll look at those as well. That can be a lot of fun. But this one, we're just saying, hey, go update the first name to whatever value, update the last name to whatever value, major to whatever value, GPA to whatever value, where the ID matches. And we know this is unique, so it's only going to update one. Technically, you can do weird stuff, be like, hey, let's go update where the major is BSCS, and we can update everybody's name. That doesn't make a whole lot of sense, but you can do stuff like that in SQL. You've got access to update off of different fields that are not just the ID field, but ID makes the most sense here. So the last one we need to map then is my paired statement, set integer to the parameter 5, student.getID. And we'll go get the student's ID out. So to update a student, they need to know what the ID is. They must have had to get the list of students here. Right? So in my code here then, we might say, hey, choice number, we'll do 3 to update and 4 to quit. Actually, we'll do 4 to delete and 5. Really, we don't actually want to delete anything ever. That doesn't really make a whole lot of sense. Which you could delete. So we'll do this while choice is not 4. Here we'll add in another if choice is 3. So to update a student, we really kind of need to know what their ID number is here. So we probably will give them the list of students or ask for an ID here. But we need the list of students here. We'll go get an ID. So we can go enter key of student to update, right? And then we want to go find the student where that ID matches. So we'll have an int for the ID is % keyboard next line. So for student and student, if the student.getID is equal to the ID they gave me, right? Once we found it here, Again, this is not ideal. It'd be better to do something. We'll come back and fix this to fix later to find just one. You want to do this in the SQL because it's fast at getting out just one record rather than loading every single record and finding the one that matches. We've got several thousands of students here, right? You don't want to have to go through thousands to find one. You want to ask the database to give you one. We'll come back and fix that later. But once we find it here, right, then maybe we print out the student here, and then we have to get the new information, right? So then we'll ask them to enter, sure, all that's new stuff again. We'll just steal this one here. Uh, I feel a little bit bad about it. I guess we could turn this into something here, right? Yeah, let's do that. So let's extract this here. So let's go refactor. We want to extract as a method. We want to call this get student. Sure. Goodness. So, oh my goodness, I didn't want a result. Okay, that was a bad one. Record result. No, goodness gracious. All right, hang on. Sorry, that is not what I wanted to do. We'll just copy. It might be easier. So we want to add a little helper function here for public student get student info. Oh, it needs the scanner keyboard name. That's fine. Print out, and then we can return a new student given all those values here. 0 for the ID, first name and last name major. It gets out all their info. Right. So then here we can just do a get student. Right, get student info. Oh, it's got to be static. Sorry. So we make it static. and we can access it here. So we get the student info for adding a student. Great. That's a nice little one-liner now. And then we can get the student info here. So we're going to tell them what it is, and then we'll get the student info. So student info equals get student info. Then the last thing we need to do is set the ID, because if I go and pass this student where the ID is 0, it's not going to match on that update command. So I need to go set my student info dot no, set ID to the ID, right? Because we found a match here. Print the student, get their info, set the ID here. Then I can call my collegedb.update student given that student info. And then I want to break my for loop, right? Stop the loop. We don't usually like breaks, but that's fine. Like end it here. That is okay for now, right? Does that part make sense? So we go print out, here's the current info. You go give me the new info. I'll go update it, and I'll set the ID to match to that new value here. And we can stop our loop. Okay, so let's give it a try. So let's go update here. I know that was student 2, right? That was Jeb's record here. It found record 2. If we don't find one, I guess maybe we have to say, hey, we didn't find one here. After we loop through and didn't find a match, maybe we could add some sort of flag and tell them we didn't find one. Yeah, I guess we'll have a Boolean for found student is false. And if we find one, then found student is true. And if not found student, oh goodness, I don't know. It's out. Didn't find. I don't know. ID not found.
I just I just feel like the way it is implemented will always get a student unless you're out of range. Right.
Well, if you don't know the ID number and I said like 27,
Oh,
we're not going to get a student back because I only have the 2 right now. But
yeah.
like eventually, when I've got 10,000 students, it's a pretty big list. I don't know if that makes any sense, but there's lots of ways to go about it.
Unless we look for number 11,000, somebody's gonna be.
Yeah, that's true. All right, so then we wanted to update, right? So we'll do first name, Feb, Solvolchernesky, BS, CS, and we'll say 4.0, right? We'll update a GPA. Then we go read all of our records back out, and now the GPA is 4.0. We didn't change anything else. We could have changed any of those fields. We only changed the GPA there. Oh, there's an extra space in major. What happened there? Why is there an extra space? Oh, it's in all of them. Did my split not work right? They all had an extra space there. Oh, because I did have spaces. These should all be trimmed then, so I should use trim. Dot trim. Dot trim. Right, on my string. That'll trim off the leading and trailing spaces here. That's why I had all those records with spaces. That's a bummer because it was comma space. My bad. Anyway, so now we can update for our records. So that feel okay so far? All right, very cool. Delete, similar idea. You use a delete statement. Again, deleting is generally considered bad form because you don't want it to blow away a bunch of stuff, right? And if a student has enrollments, we can't delete them because you don't want to delete their enrollments. And there's ways around it here, but for now, we'll just pretend like we never delete stuff. But it's probably easiest. Um, so what you guys are going to do is finish this. I get student here. We need to add the rest of the info. How do I add my courses? How do I list my courses, update my courses? How do I add sections? How do I add instructors? And how do I add enrollments? Okay. If you want to use a Java FX program, great. If you want to use console-based application, that's cool too. Whatever your group wants to do, that's okay. We'll be doing Java FX for the final project. Doesn't mean you have to do it for this one. Right? Whatever you'd like to do for this one's okay. I'm okay with either one. Um, Doing it with JavaFX is a little bit of fun because you've got your text boxes and buttons to click on, and like you can have, hey, here's my list of students, and here's my different pages if you wanted to do that, or you got lots of options here. The menu gets to be a little bit awkward here of like what table do you want to manage and stuff like that, but that's fine. Anyways, going to work for you here. So let me go add that the canvas. Oh, I had canvas open already. There we go. And then let me do a new repository for this one here. Make a new Java repository. 296 for this is project 4 now, right?
Yeah.
296 fall 2025 project 4. I think I have my Java template. There we go. So if you want me to set up shared access email, I might have missed an email from people. It was crazy with all the Canvas notifications. I'm sorry. And I was sick last week. That was a miserable week. So I can set up shared access so you can all commit and push the same one. I just need your GitHub usernames here. So let me actually make a group here. So in
You make a discussion as well.
so when I make group pages, it'll add that for you here. So let me stop recording because or let me pause it here. All right, I made the groups. You can add yourself to groups in the people section. I can't click it; it'll show everyone's name. Um, so we're going to finish out the application here. Create, read, update, delete. Delete's only for enrollment. You don't need to delete from the other tables. For faculty, course, section, and enrollment here. Add those ones in. And graphical, if you want it. Console-based, if you want it. That's perfectly fine here. So we got 2 weeks to work on this one here. It's a lot of going over the same stuff. And let me show you the last bit here was how I can get a single student back out. This little to-do I wanted to do. So in my college database here then, a get students is going to get me all the students, right? And if I want to get just one student out, let me essentially copy this here. Now we could either pass in have a parameter here for an ID, but then get students is named kind of wrongly here. So I kind of like the idea of just making another function for get student rather than adding an optional parameter just because the name is a little bit funny. Is that it's a lot of the same code and I feel a little bit bad, but that's okay. So it's get student, give it an int for the ID. So we're not going to return an array list of student. We're just going to return a single. Well, maybe we can return an array list because it will be empty if we don't find it here, or it'll have one student if we did find it. And that's probably the safest here. So we say select star from student where ID equals something. So we're going to make this a prepared statement again here. So we'll go back and prepare a statement. We need this part here. We'll make this our prepared statement. Select from where this one matches, and then we'll go and do the binding here. So we'll set the integer off of the ID. So this is just parameter 1 and the ID we were passed here. Then I need to go and run it here. So then prepared statements, my result set. Result set students query, my prepared statement dot execute query. And oh, I can't reuse ID here. Shoot. That's probably fine because I knew what the ID was. Don't even need to read that one out. That's fine. We'll just get here's the other values out. I know what the ID was because we found it. If results query doesn't come back with anything, this doesn't run, and we'll return a blank students list here, or an empty students list. It'll still give you an array list here rather than a null result, because we could give you a student or null. Dealing with nulls is a little bit ugly, and then you have to be careful dealing with nulls here. So it's probably better to just go and say, okay, I want to go get the student then. So instead of this one here, right, we don't have to use this one anymore. We can get the ID, and we can have a um, nope, students. I guess it's the same one here. Sorry. We'll just do it after. Move it down to here. Oops. STA. Get student of the ID here. Right. We'll pass it the ID, and still the loop can work because if there's one, we got the result back. If it's empty, this loop doesn't run, and we never found a student. And we just tell them, hey, the ID wasn't found. Right. Uh, but that way, now our update, we're not going to go and get all the students out of the database. We've only asked the database for one record, right? And we either got back the one record or nothing, and nothing else should have to change here. Let's just make sure it works real quick. So we'll try and update record 2, Jeb, Sobol, BS, CS, and I don't know, let's do 3.5 here, and let's list them all out. And look at that, it even took care of the spaces because we were trimming. So we go update record 1 as well, Eric Chernesky, EG 3.7, and read all those out, and we got them updated here, and all the spaces are gone, and we'll go and quit here. All right, so that's a single one, right? You can use that where clause to give you just a single result. Now, again, you can use wheres on other things. Like if you want, hey, here's the dean's list where the GPA is greater than 3.5, and you can use relational operators in SQL, right? Off numeric values. SQL does a lot of really cool stuff, and you can get that from the database level. Which ideally, we want the database to do that work so that we don't have to filter in memory because that's less efficient, right? Databases are generally good at this sort of thing. They should be able to run their where clauses pretty quickly, and they're good at stuff like that.
You said use a binary option, right?
For blob data, yep.
Okay. So we can have like in these lists, so like 0 or 1, or withdrew 0 or 1.
Well, so you could add another field, yes. So if you wanted an enrollment, you could change the table to have a field for. So I think we would probably just use the grade field to have a dropped grade or withdrew grade, that sort of thing. Again, lots of different options here, depending on however we want to store it, it's fine. Let me go commit that last bit here, and then I think we're pretty good. Yeah, so your DB file is going to change anytime you touch it. Right? Just let it change, and it's like, hey, it's binary. That's fine. We don't care. And we added some of the stuff here in our functions here. So here's added get student. All right, cool. Commit and push. All right, anything else? Can I stop recording? Awesome. Thanks for hanging out, guys.